You might think of this as sci-fi, you might think of this as fiction, but there are some real elements to this story that we need to start paying attention to. In December and January, so December of 24 and January of 25, things started to change as it related to robots, specifically AI and robots. Many of you know we've had robots around since the 1960s. We've had AI now around for a few years. What we haven't really been very good at yet is combining AI and robots together. There are a few things, and you're starting to see now more and more people talking about physical AI, the movement towards putting AI systems inside a physical system, autonomous mobile robots, autonomous mobile vehicles, all of these using the same technology, adaptive autonomy or intelligent robots. Ultimately, what changed over the past few months in December, January timeframe, certainly of 2025, January 2025, is the advent of World Foundation models. Now, most of you already know or well advanced in the idea of LLMs, large language models. You ask it a question, you get an answer. You ask it to do something like create a picture, you get an answer, or create text, or create music, whatever it may be. But you're asking a cognitive system a question and getting an answer back. That's an LLM. Now, what happened in January of 25 is we started to be able to leverage World Foundation models. Now, for autonomous vehicles up to this point in time, we've had to train these vehicles with hundreds of millions of hours of video in order to be able to get the data that we need to train the system to be able to do the kinds of things that we want them to do. That's really, really problematic in trying to get that much data into these systems overall. We needed a way to simplify that data and simplify how these systems work. Now, what we've been able to do is, in the creation of a World Foundation model, we create synthetic data in many cases. We replicate the world, physics, the laws of physics, left, right, up, down, all of these types of things we replicate in the world model. Now, when I ask a robot to do something, it interprets that question and interprets the world around it without me having to train specifically all of the elements that that robot is allowed to do. Now I have a semi-autonomous or autonomous robot that is interpreting the world using physics, not necessarily a large language model. That's the shift. And we can all put that on a chip now, and that chip can be put into a robot to allow that robot to function autonomously in the world by interpreting the world directly using physics. So that's where we're today, and the kinds of things that we're talking about happening over the next few years. We're already seeing people like NVIDIA, Jensen Huang, and others saying this is probably the most significant financial shift in the world of AI that we're likely to see over the next few years. It's roughly a $4 to $5 trillion market once we get these types of systems online. But how far can this go? And in this question, I really want to bring up a movie clip in this case. Some of you may remember this clip. It's a very short clip, but it's a movie called I, Robot. Now, in this movie, it takes a look at the year 2035. This is a very short clip. But I want to grab this clip and we'll have a quick conversation about what it means. But I want you to listen to the numbers of robots that are discussed in this clip in the year 2035 in the movie.
We are on the eve of the largest robotic distribution in history. By Saturday, there will be one robot to every 5 humans. These robots are the realization of a dream, Dr. Lanning's dream.
So what you heard, in this case, we are getting ready to launch in the movie, if we were living in the world of the movie in the year 2035, one robot for every 5 people. Now in the United States, that would mean 68 million humanoid robots. Not likely to get to that point in the year 2035. We're likely going to fall short, maybe 13, 14 million humanoid robots during that time frame rather than 68. So I don't want you to think we're going to have humanoid robots on every street corner here in the next few weeks, but you are going to see more and more of them in different forms here in the very near future. But let's look very quickly at what the state, at least right now, of robot density looks like. So a couple of things. We look at this by country right now, and right now the best data to give us a sense for how many robots do we actually have in circulation is in the industrial sector. Now, I'm going to try and differentiate industrial robots and service robots. That's an important distinction because most of us, certainly as we talk about robots, we think immediately of a factory, manufacturing type of facility or construction type of facility that we're going to be using these robots. The reality is only about 20%, 25% of the revenue forecasted in the robotic environment is related to industrial robots over the next few years. 75% of that revenue is actually related to service robots, which is anything outside of the industrial sector. We will see more robots outside of the industrial sector than we will see inside the industrial sector. But we're still using the industrial sector as a sort of guidepost for who's doing more with robots than the others. So we're going to use the data. The best data we have is a 2024 report, which is using 2023 data. So as you can imagine, this is likely to be a little bit more dense than we have in the data today. But let me give you a sense. Number one, South Korea. Roughly 1,000, a little over 1,000 robots per 100,000 people working in the industrial sector. Now, what's really interesting in South Korea, that's about 10% of the total workforce. 10% of the total workforce in South Korea today is, in fact, robots, some form of robots. So they're in first place. Next to them is Singapore. Again, what we're starting to see in South Korea and in Singapore, there is a labor shortage. That is a challenge that these robots are trying to help us solve. We don't have enough people to do the work that we want them to be able to do to keep the economy moving. So let's use robots in order to sort of make up that delta. So we have South Korea, number one, Singapore, number two, number three, China. Now, China is moving very, very fast into this space. You're going to hear me talk a couple times about the Chinese statistics and the data and what they're trying to accomplish now. But really, really interesting, they're trying to create the entire supply chain for robots in a very concise way in order to manufacture these incredibly quickly, certainly by 2027. Because they're also experiencing or concerned about experiencing a labor shortage. So China is in third place. As we think of robot density around the world, we have to go all the way to about 10th place before we hit the US. What's really interesting about this is the US, certainly from a research and development perspective, we're driving a lot of the R&D around robotics overall. But we are not the leader in robotic manufacturing. We're not the highest density in how many robots we have per 100,000 people in the manufacturing sector. This is a question and a concern moving forward as to how fast are we going to be able to make these? How fast can we keep the economy going, knowing we're having a harder and harder time getting people to work in certain jobs? So US is a little bit behind everybody else. Now let's look at a quick forecast, because where is this going? Really interesting to see. We are highly likely to see a faster and faster acceleration in the use of robotics over the next certainly 20, 25 years. And those are going to go up pretty fast. Again, what I think is interesting when you look at this, so starting to think about 4.1, 4.5 billion robots around the world on forecast by 2050, the largest percentage of many of these forecasts are autonomous cars, autonomous vehicles, followed by domestic cleaning robots and drones. And again, keep in mind, about 25% of the revenue generated is for the industrial sector, 75% outside of the industrial sector. Hence why many people tell me, Hart, this is not my expertise. I don't need to know anything about robots. I'm not a manufacturer. This is not important. The reality is this is happening, and it's going to happen across all sectors, to include household and consumer electronics. So a couple of things to keep in mind. Now, the first big test is about to happen. The first big test to see, is this type of forecast real or not? Are we really going to see an acceleration in the use of whether there be humanoid robots or other types of robots? And that is a company called Unitree. Now, Unitree is a robotic manufacturer. They have a handful of different types of robots that they sell commercially today. They are already generating a profit in the sales of those robotics. They're about to go IPO. Now, they're going to go IPO in China. They're going to go Q4 of this year. They are anticipated to go IPO at $7 billion. Now, if that happens successfully, they go IPO roughly $7 billion or better, you're going to see a whole lot more people say, you know what, there's money in this. We're going to continue to invest. We're going to move faster and faster into the world of robotics. So 2025 is the year where robotics comes into its own from a financial perspective. And it's going to go faster and faster and faster. Now, why do I say that? Why do I say we're going to start to move further and further, faster and faster into the world of robotics? I'm going to show you the next video. Now, this video talks about some of the manufacturing processes that are going on right now in China. He's going to talk about two different elements to this as to how we use robots in the manufacturing sector and how we use robots to build robots in the manufacturing sector and what this looks like now. Let's watch and see what this reporter talks about as it relates to robots and manufacturing.
Good morning. There's an old joke about the factory of the future. The modern factory will be staffed by a machine, a man, and a dog. The machine will run the factory. The man's job is to feed the dog, and the dog is trained to bite the man if he tries to touch the machine. China's already there. This is news from Xiaomi. Xiaomi is a manufacturer of smartphones, and they've opened a smart factory that will produce a smartphone every second. That's 30 million phones per year with no people. So this is known as a dark factory here. This plant is $330 million. And this is the press announcement from Xiaomi, which will use this factory to produce their Fold 4 and Mix Flip smartphones. There's a big dog in that place somewhere. And here's an announcement that sounds like the script for the Terminator. China's got a factory of robots building other robots. One robot every 30 minutes, 30,000 robots a year. And the supply chain is all right there in Chengdu in Guangdong province. Over 80% of the products to build those robots come from nearby suppliers. Production costs have been cut by a third, delivery times by 75%, from months to weeks.
So now you get the sense for how these types of systems are likely to come online and how they're likely to accelerate. We refer to them as dark factories because I don't need lights, I don't need heating, I don't need air conditioning. They work 24 hours a day in many cases. And we're starting to see these types of systems roll out, not just in places like this, but we're starting to see everything from Walgreens, CVS, prescription medication, how these systems are starting to be able to get incorporated into very complex type of environments where, again, we're labor constrained, time constrained. Let's leverage robots to be able to do the work. Should it make sense to do so? Is it financially viable to start bringing robots online? We're going to talk about that as we go through this presentation. What are the numbers? What do the financials look like? In order to do that, we have to separate the robotic community. We already separated industrialization or industrial robots versus service robots, two different kinds of robots. We're also going to have to segment sort of special use or single use case type of robots versus general use. When I say general use, now we're really talking about the humanoid type of robot. It can do lots of different things depending on what it is I ask it to do. Rather than a single use, it's just going to do the same thing repetitively over and over. I still may use automated systems or AI systems to be able to leverage and be able to manipulate those robots, but they're in effect doing the same thing over and over. Now, when you start playing this out, what does this really look like in real life? I'm going to start with single use or special use case robotics, at least over the past, let's say, 3 weeks. What's starting to gain some traction in the community overall? And I'm going to show you the next video, and then we're going to start transitioning from these sort of single use cases into more of the humanoid general use case environment. So here's the next video. And in this case, what we're starting to see, this is from a conference. And when I hit play, you're going to see a couple things happen at once. Right now, you're going to see 2 AI robotic arms. And in this case, they're going to start to fold napkins. Now, you might say this is not really a great use case overall until you start thinking about, well, let's look at cost and let's look at things like, for example, hotels or event centers, venues. Does this start to make sense? And then expand it into other elements, whether it be towels or sheets or other kinds of things in the hospitality sector. So I'm going to play this and I'm going to give you some statistics about this specific company and what's going on with them. So you're going to see these 2 robotic arms start to manipulate the napkin. Doesn't necessarily seem that complex, but the computer and the robot is starting to have to think or see what's going on and make adjustments. You can even see it's adjusting the towel as it goes through. The company's name is called Dyna, and Dyna is starting to gain some traction specifically based on some of these demonstrations. Now, this specific system ran for 3 days straight at the conference, and it only dropped a napkin once, according to the information that came out of this test. So it was 99.9% accurate in this specific task. Because of shows like this and because of demonstrations like this, Dyna is now valued at roughly $600 million US. The money is starting to pour into the sector. The sector is starting to accelerate because the technology came online with the World Foundation models starting in about January of this year, starting to make things actually function the way we would hope them that they would function. So this is just one simple single use case to give you a sense for how this may work, and the costs are relatively low overall. Okay, so with that, let's start talking about general purpose and where are we with humanoid robots. This is the one that everybody loves to talk about, looking in at sort of eye level with a robot that has hands and feet and can do a lot of the same kinds of things that we can all do. There are a lot of different types of these. There are hundreds of companies that are trying to drive down the humanoid robot environment. Boston Dynamics, Apptronik, Tesla in their Optimus robot, Unitree, which I already mentioned, going public, Figure AI, Agility Robotics with Digit, UB Tech, which is a really interesting one called Walker. I'm going to bring that one up here in a minute, but I want to give you a sense for some of the things that are happening right now in this environment. First, manufacturing. Right now, we're seeing companies, by the end of this year, many of these companies want to have a few thousand, 5,000, 10,000 or more humanoid robots that have been completed. There are some challenges in the manufacturing process of these humanoid robots right now, specifically hands. Tesla's Optimus robot, they've already come out and said they've got a bunch of robots sitting that they've already manufactured. They said they want to have 5,000 manufactured in the United States by the end of this year and working on a factory floor as part of the test environment. Many of those robots are listed. Now, no one knows. It's somewhat highly secretive, but they're referenced as sitting on the sidelines, and they're waiting for different components. One of the components they're waiting for is hands. 5 fingers, hands. The hands in the human body have about 27 different ways you can use them. In robotics terms, it's about 27 different degrees that we have to try and deal with a robot hand, degrees of motion. Then you have sensor pads. You have all kinds of things you've got to put into the hand so it understands what it's grabbing. With that, what you start to see is that a lot of in the robotic community, they're either dealing with 2, sort of a pincher, 2, call them 2 fingers, right? And they're not having to deal with the complexity of that. Some of them are already starting to move into 3. So there's the pincher has sort of 3 fingers rather than a 5-finger hand. The question is that still viable? Is it still commercially viable? We're going to talk about that, but this is one of the challenges that many of those in the robotic community are having a hard time dealing with to try and figure out hands in the robots themselves. The next one is energy and batteries. Now, this is a really interesting part of the process, and I'm having a lot of conversations with a lot of different people about the battery component. How long do these things work? What does it look like? How does this actually function? Many of the humanoid robots, in this case, are functioning maybe for a couple of hours, 1 to 2 hours, depending on what it is you're asking them to do, and then they need to recharge. So the battery life, based on the size of the robot and what it's actually doing, is not very long. And so it either has to go back and recharge into a recharging station. Maybe you have a replacement. We're going to talk about that in a minute. You have a replacement that goes back out if you're going to use it in the commercial sort of operating environment. The second is, and this is where UB Tech has come up with a very interesting solution to this, and their Walker robot, it will actually walk over to a battery station. And you get it from it, the battery comes out of its back. It actually reaches around, takes the battery out of itself, puts it in the rack, and puts a new battery in and goes back to work. So you're starting to see very creative solutions, knowing these things take a lot of battery life. They take a lot of energy in order to be able to use them. But there are still more and more challenges that we have to deal with. The next one is walking. And so when we talk about how we utilize these types of robots in the real world, we start to realize they're not necessarily great on obstacles or stairs or ramps up, down, left, to right. If everything's flat, if everything's easy for the robot to understand, it's not too bad. But as soon as I put obstacles in its way, it becomes a little more complex. And so with that, I want to show you what the state of these robots look like. Now we're going to go and I'm going to show you a video. This is the World Robot Games. This was about 3 weeks ago in China, in Beijing, where they had a handful of the robots that I just listed in competition with each other. I'm going to show you the winner, which is a Unitree humanoid robot, go through the obstacle course. So it's going to take about 2 minutes or so to show how this works on multiple obstacles. And then we're going to come back. I'm going to tell you a little bit of maybe the secrets behind what this system was doing at the time. So here we go. We're going to see the World Robotic Games champion, the Unitree humanoid robot.
现场非常的共情，因为不会因为他们是钢铁机器人就不太去关注他们的摔倒，再响起了掌声。好，现在有些机器人已经走过了第10路，哇，速度很快，崎岖路，并不崎岖了，还是跑得很快的，一骑绝尘。对，然后爬上来到直线台阶，稳扎稳打。第一步差点被绊倒，哇，脚步轻快耶。 他那个脚可是挺小的啊。对。好，我觉得绕桩可能对于他们来讲不是一个特别大难度的。
其实这种细小的障碍，有时候如果你的导航不够好的话，很容易被阻碍住。就是它很容易被卡住，一旦卡住，对，所以它可能就需要再费一些时间。
这白老师一语成谶啊，说卡住就马上卡住了。好，现在已经绕过了刚才卡点，S 型绕弯。是的，天宫刚刚在这个环节还相对是比较快的。好，连续斜坡，
跑得很快。
哎呀，连续斜坡真的是太灵巧了。这个速度越快，其实越安全，对吧？跟人类也是一样啊。对，这个是一种仿生的哈。现在他每一次就第一步啊，容易被绊倒，他躲过了，后面就很顺利。是的，现在又进入了螺旋台阶。其实螺旋台阶还是有点难度的呀。下坡让我们非常的揪心，到底宇树科技的 G1 机器人是否能够安全的走下来？非常棒，现场也响起了掌声。上一位天宫可是跟着就摔倒了。对，上难度的螺旋台阶已经顺利通过。再来看跨栏，非常漂亮，很漂亮。现场观众也报以雷鸣般的掌声。是的，这一场比赛大家在现场很关注，而且非常的共情。好，现在是交叉的步态和刚刚天宫的步态是完全是两个风格。是，你是一个特别牛的小伙子，一个年轻帅小伙。是。那天宫呢？天宫有点像武夫，就是大将的那种中年人。交叉斜坡。好，现在是对称斜坡。越过了最后的障碍任务。
时还2分32秒3。
All right, so there is the winner of this year's Robot Olympics, the Unitree humanoid robot. Now, a question just came in, and some of you probably were paying attention to that video and saw that there was another individual holding something as this robot was moving down through the process. So in this case, what you'll see in many cases with robots themselves, humanoid type of robots, you do have a handler. You have an operator overall, different ways that that operator can be leveraged. I'm going to talk about that in just a few minutes when we get into full sort of use model, use cases. But yes, there was an operator moving forward and backward, left and right, trying to line things up in order for the robot to keep moving. Now, having said that, that's about all he was doing. The robot had to sense all of the other elements and reorient itself. And I'm going to talk about how it does that in a few minutes. And I'm going to show you live how that looks. So there is an automated element to the robot once it starts moving, but start, stop, left, right, those kinds of things were done by the operator itself. It was a combined process. Most robots you see today on TV, on stage, wherever they may be, somewhere in the system, highly likely there's an operator. You may not always see the operator, but there is an operator, and we'll talk a little bit more on how that goes. So this was a bit of a really interesting challenge. I can tell you, for those of you that want to look this up and look at some of the other runners throughout this process, there were a lot more failures than there were successes. And some of those failures were catastrophic, falling down the stairs. That robot is not necessarily going to be put back together that quick. But this one made it all the way through, and you can see how the technology is starting to get better and better and better. Okay. So let's move on to another type of robot. This is a little bit easier for us to deal with. This is a quadruped. So what we've been talking about, a humanoid, so bipedal, or 2 feet overall, just like a person. Now, in most cases, we prefer a person type of robot to be able to do things in the real world that replicate what a human would do. The world is built for human beings, so why not build a robot that kind of looks and feels like a human overall to be able to do the same task? Tables are virtually the same height. Chairs are virtually the same height. You can kind of see why would I want to have something that sort of looks or acts like a human. But in certain cases, a quadruped is easier to manage. The stability and movement elements of a 4-footed type of robot than a 2-footed robot are immense. There's a lot more things that are a lot more stable on how I deal with a robot if it has 4 feet rather than 2. Cost. Because of that stability and movement and some of the efficiencies I can gain by creating that 4-footed type of process, the cost begins to come down. In fact, we're starting to see the average, and I'll talk about some of the costs, but we're starting to see the average cost for humanoid robots starting to come down. We're starting to see quadruped robot costs starting to come down. In fact, now we're in certain cases, sub 10,000. We're a few $1,000s for certain types of robots. That's where we are today. Interesting. That might be a surprise to some people to think that we're only a few $1,000s to buy some of this equipment. Next was energy consumption. In the 4-footed model, it's a little bit easier for me to deal with the battery weight. It's a little bit easier for me to deal with how much energy this is going to consume. So I may get double the amount of time on a single battery charge, so 4 hours, rather than maybe a 2-hour on the humanoid type of environment. The last one here, and I can speak to this one from personal experience, and the rest of the team here as well can speak to this from personal experience. Seeing a robot dog move around can be a little unsettling. Other dogs really haven't realized what this thing is. They don't like it. Children don't necessarily like it. There is an uneasiness about seeing a robot start to move around in your space. It's going to be an important part as we start to think about how to integrate this into our organizations, should we choose to do so, is that uneasiness. How are we going to deal with the human capital element of this as we start to look and see what these kinds of systems can do? So with that, I want to show you a quick video of a quadruped robot and give you a sense for what it can do. Then we're going to come back from that. I'm going to show you what the robot sees. Like, how does it actually function? How does the operator versus how much is controlled within the system, the robot itself? So I'm going to do two different things, and then I'm going to introduce our guest for today. So let's look and see what a quadruped can do in the outdoor type of environment and in an office type of environment. Okay, so we just to clarify, to make sure everybody is with us, there are a couple things to keep in mind. One, you'll see the robot move around on 4 feet. You'll see it move around on 2 feet. You'll see it move around handstand or on its back legs. You'll see it do all kinds of different things. Now, that was semi-operator controlled. So in the same way you saw the obstacle course was the same way we were running this. Now, to keep in mind, yes, we're telling it to do things. Now, we could turn on voice control, and in this specific model, you have both the opportunity to go voice or to use sort of different types of elements to control it. If we go to voice, that means it's an LLM. So I'm talking to, in this case, it would be ChatGPT 3.5 is the one that actually is connected to the device. I would tell it what I want it to do. It would interpret that into a command, and then based on the command, it would do what I want it to do. So it is possible to leverage that entire system hands-free, should you choose to do so. But I do want to show you, because I think it's important to understand what this system is in fact doing. It's got the world model embedded on a chip. It's doing everything local. It is not sending anything to any sort of cloud provider or any data center or anything else that it has to connect to. Everything is done local unless I go voice, and then it requires an LLM, and in that case, it is sending the information out. It is interpreting the world through LiDAR. And what I'm going to show you here is an element of LiDAR. I'm going to play this quick video, and LiDAR specifically, as you watch this video and see what it sees objects, and it sees objects by using light detection and ranging, which is what LiDAR in fact stands for. It is sending out lasers at a really, really fast rate, looking at the reflectivity of those lasers and sending it back to the device, saying this object is really close, this object is really far. And it color codes that process so the robot understands where to go and not to go. So let me show you what LiDAR and this robot actually sees. And what you'll see in the corner of that screen is the camera shot of what that robot sees. Now, it's not using the camera to help it navigate. It's using LiDAR to navigate, but the camera just gives you an idea. There is a camera mounted on this robot and gives you an idea of how it interprets the real world into these objects and allows itself to begin to navigate. So I can put this on an automated mode. I can walk around with it. If it sees an object in front of it, it will avoid that object and move around it and come back to me should, again, I choose to use that mode. So with that, here's what I want to do is I want to introduce our latest addition to the FPOV team. Now, the robot you saw, the quadruped robot, is a Unitree robot. And with that, here he is in studio. So what you see in this quadruped robot right now, the battery is embedded in the torso. You have the 4 legs. Those 4 legs have sensors on each leg to give you a sense for, give the robot a sense for where it is on balance. It has this sort of spinning thing on the front, that is the LiDAR. So as that begins to spin and move, it is sensing all of the objects around it. The camera is mounted on the very front of that device. So now we have roughly 25 pounds. So it's not that heavy necessarily, relatively easy to move around. And we get a bit of a sense for how this can work. So in this case, let's have it do a few things just so you can see how this device works. So we'll have it shake, go up on 3 legs, move that foot and back down. One of the things you may have seen on camera earlier is it does a bit of a heart emoji. So it'll sit back on its hind legs. It'll use its front 2 legs to simulate that heart. There we go. And back down to all 4s. It'll stand on 2 feet. You kind of saw that a little bit. It will move back, forth. You can walk around like a regular person. Now, what's interesting about when you put it onto this mode, the AI element to this actually begins to kick off, meaning the LiDAR is not pointed in the right direction, so it's not able to do all of the same kinds of things it did before until you bring it back down to all 4s. And as soon as you put it back down to all 4s, it, again, using voice commands, it will tell me it now can avoid obstacles. It'll follow you around should you choose to do so. It follows you around through sort of an invisible leash. It's a Bluetooth device you put on your belt. You saw maybe in the earlier video the robot follow an individual around, and it's doing that through a Bluetooth local connection. So with that, you get a sense for what these types of things can in fact do. It can jump forward, it can move backwards, it can move sideways, it can dance, it can do a lot of different types of things, to include a handstand, again, should we ask it to do so. But fairly impressive type of device overall. A couple different versions of this type of Unitree device that allow you to become fully programmable. This one's semi-programmable, which means we can program it to do certain things over and over and over. Again, paying attention to the battery usage and how long we can actually leverage a specific charge. 4 hours is about normal for this one. It takes about 2 hours or so to charge, to give you a sense. So you can leverage that, and this could be used sort of repeatedly over a period of time. Okay, so that gives you a sense for who our robot dog is. In this case, the name is Detail. So thank you, Detail. I appreciate the quick demo. Now, as we start to go into more and more of what these robots can do. Now, in certain cases, it may feel a bit like a toy overall. It's interesting. It's important to start to learn the technology and figure out what it can and can't do. But even with the device you just saw, this Unitree robot, is there commercial uses today that make sense for devices like this? Interestingly enough, the answer is yes. So I'm going to show you the next video. This is inside a factory. This is inside a factory in Singapore, although they're using the same format outside of Savannah, Georgia. They're using it in Maryland. There's a handful of places that are using this very same type of model. Now, in this specific factory, about 70% of all of the work done in the factory is done by robots themselves. Then you have a command center, sort of think of it as air traffic control in this type of environment that's watching everything to make sure it functions correctly. But I want you to see how they're using the dog, and then I'll tell you a little bit about how this whole thing has played out for them. So this is Hyundai in Singapore. Hyundai actually bought Boston Dynamics in 2021, which is one of the reasons why they're a bit ahead of others as it relates to robotics.
This is Spot, a robotic quality control dog. It's in charge of inspecting this engineer's work here at the Hyundai Motor Group Innovation Center in Singapore.
So what you're seeing here is an example of innovation in action. So we're using Boston Dynamics Spot robot to assist our technician with inspection work. And what Spot is doing here is following our technician in his footsteps and controls specific activities that are typically highly error prone. Spot will take a picture, send it to our command center where our AI algorithm will run and compare it with good and bad assembly and then return an answer whether the assembly has been done correctly or not. Before the job is done, the technician will know whether he needs to do any correction.
Opened in 2023, the factory can produce up to 30,000 electric vehicles annually. Hyundai says almost 70% of their assembly and inspection processes are automated, with around 200 robots on the factory floor.
The value of using robots-assisted inspection rather than human inspection is the consistency. So you really need to have that type of accuracy there if you don't want to have quality issues down the road.
Okay, so that was the Boston Dynamics version of virtually the same type of system. You can see it was following it. In this case, it mentioned following an individual, highly likely to be a Bluetooth type of device on the belt overall. Then it goes through a sequence of taking pictures to see what was going on underneath that vehicle before it moves on to the next space. An interesting use for this type of robot in a commercial environment. Now, interesting enough, as soon as it's finished, it goes back to a charging station. So it's constantly going back and forth to charging. Now, something to keep in mind, this took about 12 months to program. I'm going to bring that back up when it comes into costs and some of the challenges on how to implement these robots as they exist today. So a few things. One, keep in mind environmental design. You saw the obstacle course. If you're going to start to think about leveraging robots, and certainly we're using more and more in things like landscaping, we're going to use more and more in healthcare and elder care. We're going to use more and more in agriculture. All of these things start to become important to us. But environmental design, if we're going to use them in a human-centric environment, stairs don't work well, ramps don't work well, obstacles don't work well. Mercedes-Benz figured this out. They had to reestablish or refigure their manufacturing floor based on the need to use these types of robots. It wasn't going to work for them. OSHA in the United States has not promulgated any rules, any regulations about automated robots inside the workplace. Safety of individuals, being able to work around these systems. Typically, the safety type of environment, if we have a robot in a manufacturing area or whatever it may be, we rope it off. We have tape on the floor. We say don't move until you have a lockout tagout system. We know it's safe and secure, then we can work on it. But if it's fully automated and moving around, that doesn't necessarily work. The overall manufacturing process has to pick up a few thousand this year, 10, 15,000, 20,000 this year. We'll double, triple that next year, and we'll move on forward. But you're going to see it's going to become more and more important to manufacture faster and faster. Within your organizations, you have to start thinking about how many of these do I want? Am I going to think about average demand, peak demand? How many do I want functioning at any given time? Amazon has already reached 1 million robots to 1.5 million employees in their ecosystem. But thinking about, do I want to manage peak demand or average demand? How am I going to flex if I need to move faster or slower? The more robots you put into a specific area, the more problems you're likely to have. You can actually over-robot a specific small area. Trust with people. This is a big one. A lot of people don't trust these systems yet, which is why we have operators and they're not fully automated. In certain cases, we've already seen we have robots working in a specific area. We have other people behind the scenes, not even in the same location. They're wearing a Quest 3 type of headset, a VR type of headset, and they're monitoring to make sure that the systems are doing what they're supposed to be doing, hit a stop or correct if they need to. So we have an automated system working with operators behind. Even if they're not doing anything actively, they're still paying attention, but not fully automated in most cases today. Highly likely you're going to start thinking about, do I need a fleet manager, a robot fleet manager, or have to deal with robot fleet management. The more of these systems you're going to bring online, the more I'm going to have to deal with the challenges that come along, just like with a car or anything else. Now, one of the questions I'm sure a lot of you are asking is, what are the cost structures? An average robot right now, humanoid robot on the market, if you were able to get it commercially, is roughly $80,000. That's the average. It flexes up $150,000, $150,000. It will flex down, in certain cases, down to $16,000 or $10,000, depending on the system you're trying to look at. But price becomes important. If I'm buying more of these systems, am I going to have to, so the bank's starting to have to think about loans. Am I going to have to start thinking about robots as a service, meaning I'm going to rent or lease these? Now, we've already gone down this process here at the company. I tried to go and rent and lease robots. You can do it. And I call them and they're, oh yeah, it's a couple $100 a month. I'm like, that's great. I want two. Like send them over. I want to see how these things work. I'm like, no, Hart, we can't do that. We got to send 2 technicians over to you. They got to program it. It's about $30,000 to get it programmed. It's going to take, a couple of weeks to get it programmed in order for you to use it. And then it's a couple $100 a month. It may still make sense depending on the use case for that, but are you going to rent or lease? That changes the dynamics overall. If you're going to buy and the economy changes, it's not as easy to sort of manipulate or start to work the numbers to see how to become more efficient in your organizations. So these structures that we're going to have to put into place for how we're going to leverage the robots now become more important to us. The setup installation costs, highly likely to at least be half of the hardware costs per robot. So if your robot is $150,000, your likely setup cost anticipated is probably in the $50,000 to $70,000 range. Project management. Where am I going to put these things that make the most sense for my organization? It's the same thing with AI that we're dealing now on a cognitive basis. Have you done the workflow analysis to figure out where this makes the most sense to potentially try and leverage? Maintenance costs, 5 to 10% of the total cost of the device per year, at least for a few years after these systems are in place. The payback period, the ROI for these devices now is really, really interesting. Amazon has a 2-year payback. Most people are playing around with a 2-year payback based on a couple of factors. They're based on about $30 an hour US equivalency of a job, so to speak, and about between $100,000 and $150,000 per robot. Provided everything goes well, you can get a payback within 2 years. Where are we trying to get to? We're trying to get to about $20,000 a robot, a humanoid robot, that will function about 20,000 hours for a lifespan. So that's the game that we're trying to get down to. Costs are going to keep coming down as manufacturing comes up. That's the Wright's Law, for those of you that know how this sort of the Wright's Law of manufacturing and how the costs begin to come down. $20,000, 20,000 hour lifespan. Now I get an ROI on that pretty fast. The idea is, can I get it in weeks or months? Now it becomes a very compelling argument as to how many of these systems do I want to bring online. All right, last few things, and then please make sure if you have any questions to put your questions into chat. With that, staff training on risk management. There are some challenges with these, and if you see them malfunction for whatever reason, in many cases they will malfunction, whether it's the dog, the quadruped, or a humanoid robot. When they malfunction in these types of autonomous systems, they'll either fall down, everything starts moving at the same time. They can't figure out what's up, what's down, the LiDAR's not working, they don't have sensor pads on their feet, they can't figure out what is in fact happening. So just walking over and pushing the power button actually becomes a bit problematic when that happens. Liability of the systems themselves. We understand liability when somebody gets hurt in the workplace, but now I have an autonomous system with or without an operator. Where does the liability sit? And that's something contractually we got to start figuring out. As already mentioned, security, both physical security and cyber security of these systems. We don't want the systems damaged. We also don't want the systems wandering off, which can happen. So we're dealing now with trying to keep people out. We're trying to keep the robots in many cases, and then thinking through the cyber side of the house. All of these have a microphone. They all have a camera. They all have information. They all have data. They're transferring data. All of these things now start to become really important to us as it deals with privacy. I can tell you from my perspective in dealing with the hacking community and everybody else, There's a lot of people that enjoy hacking Roombas and all of the vacuum cleaners. Those also have a camera. In many cases, they may or may not have a microphone. So dealing with those elements become important. Certifications, audits, and compliance. Are these systems, just like anything else, looked at least once a year, recertified, or do you have to do it faster than that? Collective bargaining agreements. We've already seen challenges, the longshoremen, we've seen challenges with Walgreens, we've seen a handful of challenges that if you want to bring these systems in, if you're part of that unionized environment, they may not actually look at that favorably. From a technology perspective, one of the ways we're looking at trying to make a safe system is to modularize the software within the robot itself. What does that mean? Is that we create modules for the AI. The AI then passes information from one module to the other. The reason that we do that is we get better transparency as the information goes from one module to the next, which means I can audit it. I can see what's happening as it passes that information down and where that information potentially went wrong. So modularization inside the system itself to create an auditable, transparent environment as much as you possibly can with AI now becomes important. And that is one of the ways that we're starting to drive down this idea of safety within the systems themselves. Certainly insurance, both from a property perspective, these things are not cheap, and you're going to start buying, if you choose to go down this path, you're going to start buying or leasing these systems. You start thinking about workers' comp. What happens if there's an injury in the environment overall based on an autonomous system? Incident response, if something goes wrong, becomes now more and more important. And then thinking through what metrics are you going to use to ensure that this continues to make sense for you as you move forward. One of the interesting ones is overall equipment effectiveness, OEE, as a metric to say, okay, what's the accuracy? What is this in fact doing for me? Is it still making sense? Has it degraded over a period of time? Do I need to think about replacement? Do I need to think about maintenance or some other mechanism? Overall, when do these robots reach the end of their usable tenure for us in the primary, let's say, environment? Is it 20,000 hours? Can I extend it further than that and get a better ROI on it? Or is it less and I'm going to have to replace it faster and faster? So all of that being said, January of this year, we had a big shift. That shift was we can now leverage AI in the manner that we would like to be able to use, an autonomous manner, in a physical system, in a kinetic type of environment, using a world model. When I heard, and I was in person when we had this conversation, and when I heard that news, and what was quite interesting at that time, very few people reacted to the news, and I watched that and I said, wow, we just shifted gears. This is no longer a piece of equipment that can just do the same thing over and over and over again. This is something that can now actually function in the real world to our benefit. Hence the acceleration to the end of this year. China is saying this is the year of mass marketing of robots, and into 2026, where we're likely to see more in the US. Tesla seems to be a bit in the front trying to get numbers out. You're seeing a lot of discussion around what they think the future of the Optimus robot is, certainly in the United States, and what it means for them as a company. Keep in mind, this is a $4 to $5 trillion, at least estimated now, market that we're likely to see come online and continue to accelerate. So thinking through this process, suitability analysis, when and why and what's the ROI for me to do this becomes important. Thinking through what happens if it goes wrong, what's the incident response process if I need to shut it off or shut it down. And then thinking through the HR process. Is there a level of trust of these systems? Am I going to have to retrain a lot of my staff to be able to use the systems overall? What are the workplace rules if and when I have a conflict? All of these questions are going to need to get answered in the next 12 to certainly 24 months as more and more of these systems come online. By 2030, we'll have more than 1 million of these devices running around, certainly in the US. Those are a bit of the forecasts. We're likely to see this accelerate over the next few years. So with that, thank you for joining us today. I appreciate your time and attention here. Appreciate you talking about robots with us. And I do want to ensure that you stay in touch with us. So for those of you that are not connected to us formally, if you want more information on the AI Navigator, we have a think tank coming up in the next few weeks. There's still time to get into that think tank. That's September 29th and September 30th here in Oklahoma City. where Scott Klosowski will be going through more and more elements of leadership over the next few years. So I highly encourage you to attend the think tank. We also have a trends report coming out over the next few weeks, and we'll have another update coming out in November. So I want you to pay attention to all of those dates. Make sure you stay in touch with us on socials. Write us directly if you have any questions. We're here to help you on your journey, both with AI and now the physical element of AI. Thank you very much for joining us today. Have a great day.